buying stuff on sale. And we all like to buy stuff on sale. Well, sometimes. But, there's some approaches that might be worth considering. Now, here's one I often get. Some friends have asked me about this more than once. And that is, if something goes on sale, how much should I buy? And of course, there's some obvious ones. You might have a capacity constraint. Where the heck am I going to store it? And or maybe it's perishable, so you don't want to buy anything more than goes rotten. Well, you might consider the discount price as a percentage return and compare that to the opportunity cost of, say, something you might get elsewhere, maybe the stock market, and make that an annual amount. And of course, you might want to not overdo it, but it's something to consider. Here's an example. Suppose a normal price for something you buy is $5 and it goes on sale for $4.50. That's a 10% discount. And, let's see, 10%. You might compare that, say, 5%. You might buy 2 years' worth. And notice I'm actually using a conservative base here. It's something to consider. Here's a more relevant one. You get coupons. Everybody loves them coupons. And you are faced with maybe a 10-ounce size at $2, 20-ounce size at $3.80, and a 30-ounce size at $5.10, and you got a 50-cent coupon. Well, let's see. Before using the coupon, the cost per ounce would be respectively 20 cents, 19 cents, and 17 cents. But now, after applying the coupon, the prices for each of those respectively per ounce are 15 cents, 16.5 cents, and 15.3 cents, noting now that that middle one is now the most expensive on a cost per ounce basis. Boy, that's something to consider, and it actually kind of varies as whether you only have one coupon or a whole slew of coupons. Okay, let's say you don't have any coupons. It's not on sale. There are still some very effective strategies with regards to the amounts you should purchase. Something's called the economic order quantity from Baumol and Tobin, and it says look at the cost of storing your inventory, on average half the amount, and the cost of the number of trips, say, per year. And here's a graphic. You'll notice that straight line is the cost of your inventory half the time because you're above and below on average, and the declining line is the cost per order on an annual basis, and you add the two together and you probably want to be near the minimum. And it turns out, take the first derivative, I'll spare you, that when those two components are equal, you're at a minimum. Here, of course, is an example. Let's say you go to the ATM, getting $20 a week. There's 50 weeks in a year because you take a 2-week vacation, and transaction charge is an actual $3, or maybe the cost of the time and effort for you to stop by and get some dough, and the interest rate's 10%. Well, your current policy would be 1/2 of that $20 sitting idle in your wallet, above and below on average, times 10%, and the number of trips, well, that would be, 50 times a year, times $3, adding to 151. But what would the optimal quantity be? Well, let's see, our equation is, I like to use the mnemonic King Tut overseas. 2 times the usage times the transaction divided by the carrying cost. Well, let's see, 2 times. The quantity is 50 times the $20, that's the annual on 1,000. Transaction costs $3 divided by 10%. Take the square root, and it'd be about $245. And we can check our answer because putting in the original equation, we get a total of some $24.50. And notice the two components are about 12 1/4. So we know we got an optimal answer. And by the way, now you notice we would make about 4 trips a year, or about every 3 months, with Dr. C Invests.